are going to be on your test. Okay, and that's it. The derivative of a function. What is going to be the derivative, okay, of a function? There are different ways to describe the derivative of the function. You know that the calculus was, rediscovered 3 times. There is a one that's done by Isaac Newton, the British school, if you like, and the one by the Leibniz, that's a German school, and the other one by Cauchy, which is going to be the French one. So what I'm going to do is, this is the way I do it. My approach is going to be a little bit from your book, just right at the beginning, but this is the precise one that we have to know. Now, the way we're going to define the derivative of the function, we are going to take it as a machine first, because the first time that we met derivative of the function was where we talk about the what? Tangent line problem. And the interpretation was that the derivative of the function, or the slope, was the limit of the slope of a secant line. So that's why I'm going to start with that, okay? But we get everything at the end of the day, and then we'll tell you which one are going to be more precise and to do it, okay? So any question you have during these arguments, let me know, because this is going to be your lifeline for the next 6 weeks. Okay, suppose a function f is defined. I'm going to define it as a machine first. Defined on the domain. This approach are going to be a geometrical one because we use the slope. Okay, suppose a function f is defined on the domain D, and a is a number in the domain. And a is a number in the domain of the function in D. Now the derivative. This is it. If this is going to be the case, f, the function f, the first expression is said to be differentiable. That's the expression, differentiable. Okay, it's going to be differentiable at a. So that's the expression, differentiability. Differentiable at a if this limit exists, if the limit that follow the limit of just the secant line, f of x minus f of a, the slope of a secant line, over x minus a, x goes to a, okay, if this limit exists. So if this is going to be the case, if the function is differentiable, the result of this limit is going to be called the derivative of the function. Okay, in this case means if you can find this limit. In this case, now the other expression, the derivative. Okay, the derivative of f at a. Now this is going to be our second expression. Okay, derivative of f at a is going to be denoted by f prime of a, f prime of a, and is defined by what? Defined by this, the formula for the derivative, f prime of a equal to limit of exactly the one that we put at the top, f of x minus f of a, x minus a, x goes to a. That's it. This is going to be our derivative definition for the time being. Any question? So as you can see, the inside one is the slope of a secant line that we talk about it. And we check that if we estimate the slope of a second line, the result is going to be the slope of a tangent line. So that's what we talk about it, but now we put it into a kind of a formula. Okay, let's practice. Example, how we're going to find the derivative of a function. Example, as soon as we write the example, we know that you will see that this is going to be the things that we did before. Okay, so check this one. Suppose I have a polynomial, suppose f of x equal to the 7x squared plus 5x minus 1, and would like you to find f prime of 2. Remember, we don't know any formula. On the test, we are going to give you some formulas later on, but on the test, you are going to be asked to find the derivative of the function at one number using this formula only. This would be one of your question in the, or part of one question on the coming test. Okay, so you have to know this. Solution, just apply the formula. You see, apply the formula for a equal to 2. A equal to 2. So I just remind the formula. So f prime of 2 derivative is going to be equal to the limit of, it's f of x minus f of 2, x minus 2, x goes to 2. This is your formula. Substitute, simplify. I simplified separately and then I go back. Some people do it right away. It's up to you, whichever you feel more comfortable. Okay, so this is it. So I have my f of x, which is a 7x squared plus 5x minus 1. So I'm going to find f of 2. Okay, so it's going to be f of 2. Directly substitute is going to be 7 times 2 squared plus 5 times 2 minus 1. Okay, carefully simplify it. 2 squared would be 4, 4 times 7 would be 28, plus 10 minus 1. So that gives me 38 minus 1, which is going to be 37. Okay, so this is it. So then I subtracted and just put it on the top here. Okay, so this is it. So I have the f of x minus f of 2. So that gives me 7x squared. Okay, so that gives me 7x squared plus 5x minus 1 minus 37. So it's going to be minus 37. Okay, combine the like terms. -1, -37. That gives me -38. So I have a 7x squared plus 5x minus 38. Okay, so I simplified the top. So I go back, substitute, and take the limit. Okay, so this is it. So I go back to this formula that I have over here. Okay, so this is it. So my f prime of 2 now is going to be the limit of x goes to 2. So the top, I have a 7x squared. Okay, 7x squared plus 5x minus 38. And on the bottom, I have x minus 2. Okay, if you substitute these numbers, you get 0, 0. If you substitute 2, you're already done on the top. So this must be, you can go ahead and take the limit, but I just substitute, should show you that this is going to be the case. So it's going to be 7, 2 squared plus 5 times 2 minus 38. And this is going to be 2 minus 2. Again, like the top that we did. So that gives you 28 and 10 minus 38. Okay, over 0. So that gives you 0, 0. You don't have to do it, but just to give you an idea. Remember 0, 0. What's the message here? 0, 0. Message for finding the limits.
X minus 2 is a factor.
Excellent. X minus 2 is a factor. So we go ahead and we factor it. Limit of x. Of course, you know, we do everything at once. So x minus 2 is going to be a factor. So x minus 2, x minus 2. So you have to find the other factors. You see that's a 7x squared. So we need a 7x here, because 7x times x would be 7x squared. The number is a negative 38. So that's a negative 2. So negative 2 times what would be negative 38? Numbers?
19.
19, positive or negative?
Positive.
Excellent. Positive, yes. Positive, because positive negative would be negative. That gives us a negative 38. Now we can eliminate the common factor. So the result would be limit of the 7x. Okay, limit of the 7x plus 19. X goes to 2. Now direct substitution, 7 times 2 plus 19. So that gives you 14 plus 19, which is going to be 33. Okay, so the derivative of the function f prime of 2 is equal to the 33. Okay, of course, it's going to be shortcut at the end of today, but we just, just starting. So that give you anyhow we are going to operate with this formula. F prime of 2 equal to the 33. And later on, this is going to be just the slope of the tangent line. Okay, any question?
I have a question.
Yes.
For the test.
Yeah.
Can we use the shortcut, or would you prefer us solve it the long way?
Yeah, we use the shortcut, but we give you one problem just using this formula in your quiz one.
Gotcha. Okay, cool. Thanks.
Something short, of course, but because we need to make sure the next example that I'll give you show you how we are going to use this would be a shortcut. That the derivative would be 14x plus 5. We just replace the x by 2, like 33. Yeah, this is the way we do it. But why we should know this formula is like the next example. But they directly ask you to one question. It's going to be part of one question on the test. We give something easy and then we ask you to use the definition of the derivative. This means this result. But otherwise, for the rest of the 5.5 questions that you have on the derivative on the test, you just using the shortcut. Okay, but
okay, cool. Thanks.
Okay. But for this next example, which is very important in calculus, you have to use this method only. Okay, there are a group of problems in calculus 1, and especially if you want to calculus 3, quite a lot over there, that you have to use the definition. You see, you have no shortcut for this. That's it. Suppose f of x. It's very popular problem. In calculus 2, we have another method to do it. But in calculus 1 and 3, you have to use this definition. You see, we have x cubed cosine of 1 over x. They give you either a cosine or the sine, nothing else for this problem. Okay, and we have the 0 here when x is 0. Then they ask you to find, you see, find f prime of 0. You see this problem? You see, it's a piecewise defined function, as I talked about it before. For the piecewise defined function, for the partition point, always you have to use the definition. If you want to find the limit, remember right limit, left limits. It's the same thing for the derivative. There is no shortcut for this one. You are going to learn the formula for product rule, but since it's a partition point, the only way that you can do it is that definition. That's why we focus on that. Okay, so just write the definition to it. As soon as you write the definition, this will be a familiar limit. Okay, let's see what's going to be definition for a equal to 0. So what's going to be f prime of 0 is equal to the limit of, you see, just the slope. y2 minus y1 is going to be f of x minus f of a, which is f of 0, divided by x minus 0. Rise, run, it's the same thing. X goes to 0. Now substitute. X goes to 0 means X is not equal to the 0. Your function is this one. F of 0 is 0. Okay, so it's going to be equal to the limit of X goes to 0. The top would be X cubed cosine of 1 over X. Okay, minus F of 0, which is 0, over X minus 0. The simplify is going to be the limit of X goes to 0. Okay, so the top would be X cubed cosine of 1 over X, and this would be X. You know that you want to find this limit, there is going to be a common factor. X goes to 0, X not equal to the 0, so simplify by 1X. So the result would be what? The result would be the limit of X squared cosine of 1 over X. Okay, X goes to 0. What is this limit? Do you remember? Limit, or how are we going to find it?
We use the squeeze theorem.
Excellent. Yes, we have to use the squeeze theorem. Remember, you have to. So we say that this is going to be equal to 0 eventually. Okay, by the squeeze theorem. If it's going to be on the test, we accept it. But I'm going to show you, just a reminder, remember the squeeze theorem, you have to let's check the inequality. So we let the cosine of 1 over X, okay? Cosine of 1 over X should be between 1 and -1. And since you want X squared times, you times it by X squared. It's going to be negative X squared. X squared, you have 1 on your quiz. 1 over X less than or equal X squared. Okay, then we find the limit of the function to the left. Limit of negative X squared. X goes to 0, which is 0. We find the limit of the function to the right. Limit of X squared. X goes to 0, which is equal to the 0. And then by the squeeze theorem, remember, a squeeze theorem will tell you that the limit of the middle one, X squared cosine of 1 over X. X goes to 0 is also equal to the 0. Okay, but on the test, if it's going to be, of course, if it's a direct question, you have to prove it. If just the limit, but if it's coming with the derivative of the function, we accept that when you say a squeeze theorem. So eventually, the limit of the function, okay, therefore, f prime of 0 is going to be equal to the 0. You see, so that formula is needed if you want to take care of these type of problems. And this is a very important problem. The variation of this problem is in your book in various places. They change this power only. You see, that's X cubed. They give you X squared to the 5th to the 6th. That cosine of 1 over X can be sine of 1 over X. This is a group of problem, depends on the application that you want. This is going to be the case all the time. All of them would give you an answer, but if it's going to be X only, X cosine of 1 over X only. If it's going to be X, you see when you simplify here, that X disappear, that give you only cosine of 1 over X. And you know that, we proved it before for you, that the limit of a cosine of 1 over X, X goes to 0, does not exist. So that would be the only case that your function is not going to be differentiable. But otherwise, this function is nicely differentiable, and then you are done. Any question so far? So again, the shortcut would be provided. You have to be aware of this type of problems. And again, you know, in calculus 3, we get a function of 3 variables. And there are some cases in applications that you have a piecewise defined function and you need a formula. So that's why we practice. Okay, any question? So let's see what's the origin of this definition that we define. As you know that I just used the idea of the slope of a secant line that we did it before. So as we promised that we are going to solve the problem, tangent line problem, we are ready for it. Okay, so we just give you a remark to connect it to the geometry, and then we come back and we continue to find the shortcut for you. Okay, so connection to the geometry or to that problem of the tangent line problem. Okay, remark, yes, we just solved the tangent line problem. So we just remind you that if the function, as we described it before, okay, if the function f, if the function f is differentiable, now you know what does it mean. Differentiable means derivative that exists. Okay, if your function is going to be, this is it, it's going to be differentiable. Let's say differentiable at the number a, then that f prime of a that we created, derivative of the function, now it's going to be the slope. Is going to be called, we usually refer to the slope of a line. Now we can refer to the slope of the curve. It's called the slope. Okay, the slope of the curve of the graph of this equation of y equal to the f of x at x equal to the a. Okay, so that will help you to quickly generalize something that you know it before from algebra. Now we estimate it for the calculus. So this is going to be the case. So if you be given a curve, if this is going to be the curve, and this is going to be a point A, now you know that you can find you can have the tangent line. And we described it before how we're going to find it. And that's going to be the tangent line T, if you like. And this is going to be your curve y equal to the f of x. Okay, so in this case, the slope of the tangent line is going to be equal to the f prime of a. Okay, so you can call it the slope of the curve, or equivalently, if you like. So it's the same thing. Sometimes in your book, they ask for that slope. Equivalently, f prime of a can be, okay, can be considered as the slope of a tangent line. Both of them are going to be the same thing. Tangent line, okay, to the graph y equal to the f of x with this equation at the point with x equal to the a. You see, we quickly change it to our plan, if you like. Okay, so the way I define the derivative for you is exactly the way we described it before. I define it as I go with the slope of a secant line, and then I define the tangent line. So again, we can use this new notation to find the equation of a tangent line. Again, this problem would have a shortcut later on, but for the time being, we are going to just stay with our definition that we have. Any question? So from now on, just keep in mind, differentiability and the existence of a tangent line are going to be the same. So anytime we say the function is differentiable, means there is a tangent line. You see, if we cannot have a tangent line at the point A, in that case, the derivative of the function does not exist. For example, if your function is discontinuous means there is a hole here, remember? If there is going to be a gap, a hole at the point A, you'll never be able to find the tangent line. You cannot find tangent line where there is a hole here. So in that case, f prime of A does not exist. We give you this theorem later on. If your function is not differentiable, then you cannot find the derivative, okay, the function. So that would be very nice from now on. Anything you talk about it. You give me any question in calculus, I will connect that question to the tangent line. So you should be able to do the same thing to get a better understanding of the argument that we have. Okay, so for the time being, again, just solving the problem of tangent line using whatever we have so far, but by the end of today, you have the shortcut for all these problems. And on the test, you're just using the shortcut. Okay, find it. Because in your assignment, you have a couple of them. So I want to make sure you know it. Find the equation of a tangent line. Okay, the equation of a tangent line to the graph of this function. Something easy to find of y equal to the function is 1 over x. And you want to do it at the point. Okay, at the point with the x values of 3. Okay, let's see, so far with the tools that are available, how we're going to answer this question. Okay, two steps. Step 1, we need a point. This is x equal to 3. You drop it into the function to get the point. Case 2, the slope. We know that the slope is derivative, f prime of 3. We're just using the formula that we talk about it to find the f prime of 3. Okay, and then with the solution. Step 1, I need a point. It's always the case for the rest of the course. The point, I have the x. Point need x and the y coordinate. So x is equal to 3. Drop it into the function. So that give a y equal to the 1/3. Okay, so you have a point. The point P, the coordinate of the point would be 3 and 1/3. So this is going to be your point. Okay, any question? The slope. So I need the slope. But this is calculus, as we talk about it now. The slope is derivative of the function, f prime of a. What is a? Is 3. So you have to find the f prime of 3. In future, the shortcut. But for the time being, just using the formula that we have and substitute to get the result, okay? So go to the formula and find the f prime of 3. Is going to be the limit of x goes to 3. Same thing, rise, run if you like. That's x minus 3, write it on the bottom. On the top, you have to find the f of x minus f of 3. Like y2 minus y1 over x2 minus x1. Okay, bring f of x, which is 1 over x. So it's a limit of x goes to 3. So on the top, we get 1 over x minus f of 3, substitute, 1/3, divided by x minus 3, x minus 3. If you do the direct substitution, you know what does it mean? If you do the direct substitution, that give you 1/3 minus 1/3, and that would be 3 minus 3, which is equal to the 0, 0. Okay, what's the message for this one? Zero, 0, x goes to 3.
X minus 3 is a common factor.
Excellent. X minus 2 is a common factor. The top is fraction, remember? When the top is a complex fractions, we just simplify the top to get X minus 3 on the top, okay? So this is how we are going to continue. Again, you continue right away. You know, you just, it's a X goes to 3. So remember the top common denominator between 3 and X would be 3X. And the top kind of cross multiply, 3 times 1 would be 3 minus X, or just, you know, the common denominator 3X divided by X, that give you 3 times top, 3X divided by 3, that give you X top, X minus 3. Okay, remember, you need X minus 1 on the top. This is 3 minus X. What are you going to do to get X minus 3 on the top? Any suggestion? The top.
You want to multiply by -1?
Yes, or factoring -1 in this
Oh,
case.
yeah, factor, yeah.
Factor of the -1 so that X would be positive. Okay, that give you X minus 3. Sometimes we need this extra job. Okay, and that's it, 3. Now we get the X minus 3 on the top and the bottom. So we eliminate it. Okay, so we arrive at the limit of X goes to 3. So the leftover on the top is just a -1. The bottom one is 3X. Substitute X equal to 3. So that gives a -1 over 3 times 3, which is a -19. Okay, -19. That's it. So the derivative of the function, which is the slope, is equal to the, okay, is equal to the -19. So the slope of a tangent line is going to be -19. Okay, in future we have a shortcut, but not for the time being. That's it. We have a point 3 and 1/3, and we have the slope of the -19. So we are ready to find the equation of a tangent line, and we fulfill our promise that the derivative of the function would solve the problem of the tangent line. Okay, any question? I'm not done, so I have the point and the slope. So I go to the next page and I find the equation of a tangent line. Okay, so let's go and find the equation of a tangent line and fit the information here for myself. So I have M equal to the -19. Okay, that's a -19. And I have the point, which is going to be 3 and 1/3. Okay, so we're going to use the formula y minus y1 equal to the m times x minus x1. Substitute. So that give 1 minus 1/3. Okay, this is it. Equal to the m. What is m? M is a -19 times x minus x1, which is x minus 3. We have to simplify it, so that give y minus 1/3. So that give -19x, negative positive, so that give it 39. Okay, and we can simplify this. So that give a y minus 1/3 equal to -19x plus 1/3. So add the 1/3. So that give a y equal to -19x plus 1/3 plus 1/3. 1/3, 1/3 would be 2/3. So y equal to, okay, so y equal to the -1/3, 19x plus 2/3. So this would be considered to be final answer. Okay, so this is the equation. Okay, the equation of the tangent line. Of the, okay, tangent line. And we're done. Okay, so with this method, we can we can use it to solve the problem of the tangent line. Okay, so it's a nice method, but this is one interpretation of the derivative of the function. So I just use geometry to be able to do it. So what we can do is we can build a formula, a machine. You see, function is a machine, so we can find f of x for any value of x. So what we'd like to do is we'd like to build a machine for the derivative. That would be derivative machine, if you like. Derivative machine would have formulas that you can apply it and to get it. So what I'm going to do is we are going to give a break. Then we'll come back. We started over. What is derivative in physics? Okay, in everyday life, it's tangent line. Okay, the problem of a tangent line is geometry. So what would be interpretation of this one in physics? So we started over, we start with the everyday life problem. Okay, and then we introduce formulas, a collection of formulas. We introduce the so-called the derivative function. That is the approach of your book. But this is history, just read it step by step, and either one would be useful for you. Okay, so it's almost 9:07. So I give it 10 minutes, we come back, and then we start it over, give you the definition of a derivative, the way we are going to use it so-called as a rate of change. That would be very interesting, enable you to use the shortcut to do everything I did so far, but we need the history. We need to do it step by step, and we're not going to rush that one. Okay, any question? So have a break, we come back and we start over and give you the second. Some people, they call it second definition of a derivative, but it's not the second really. Both of them are the same. See you then, bye. Okay, so we talk about derivative of the function as the slope of the tangent line. Now we're going to go back and remember at the beginning we talk about calculus is the study of rate of change of the value of a function. So we're going to start it over and check to see what is going to be a relationship between derivative of the function and the rate of change. It's a very nice interpretation, and that will give you a good way, you know, to describe the derivative of the function, and in everyday life, in application, in physics, in any other part of science, we are going to use this interpretation of a derivative of the function. Okay, so pay attention and let me know if you have any question as we create this rate of change formulas. Okay, so we started over. This is the way it's going to be given you in, you know, in your book, or it's given to you, but that's precise way to talk about it. So what's going to be rate of change? So we go into the everyday life problem. If somebody asks you what is the derivative of the function, this is the way you're going to explain it. Okay, so it's very similar to the other approach that our other version that we did have. So we need a couple of more terms, definition. That's it. So let's start with the function again. If a function, I'm going to create what is the meaning of rate of change. So if a function f is given, and if we have two numbers, 2 points, and x1, okay, x2 are going to be our two numbers, in the domain of the function, okay, in the domain D, in the domain D of the function. Then we are going to define the so-called change in x, change in y, or rise run again. Then the change. Okay, the change in the values of x, in the values of the variable x, from two different values, from x equal to the x1 to x equal to the x2, is going to be denoted. Okay, it's going to be denoted by the notation. Notation is called delta x. Okay, that's it, the delta x, and is defined by, and is going to be defined by, that's it, definition of delta x. Delta x is going to be equal to the x2 minus x1. It's two different steps. So that would be delta x from now on, change in x. So, you know, if x is 1, you go to the 1.2. So the change is going to be 0.2, because it's going to be, you know, 1.2 minus 1. So that's going to be the change in x. Any question? So you drop this x into the function, so there's going to be a change in y. So there we continue. The other change, the corresponding. Okay, the corresponding change or changes. Okay, change in y, or the value of y, or in f of x, if you like, is going to be denoted, notation, denoted by, the notation is going to be delta y. Delta y, and this is going to be defined by change in y, and is defined by delta y. delta y is equal to the f of x2 minus f of x1. Okay, so the change in x would be delta x, x2 minus x1. The change in y would be delta y is the rise run, f of x2 minus f of x1. Any question? Now we are ready to define the average rate of change of the function. Okay, what's going to be the average rate of change? The average. It's going to be just the slope, like the slope of a secant line. The average rate of change average rate of change of the function f, again from x1 to x2, 2 steps. Okay, or sometimes you say or over the interval. It's the same expression over the interval x1 comma x2. Either one would be fine. It's going to be denoted by, it's like the slope in the case of the line. Okay, so this is going to be the definition that we're going to have. So average rate of change. Average rate of change of f. Okay, the average rate of change of the function f is going to be equal to, that's it, f of x2 change in y, if you like, divided by x2 minus x1, which is simply change in y over change in x. Or in the case of a straight line, is like, the popular version of the rise run that we are going to extend here. Okay, so that would be the formula for the average rate of change. Any question? So you see, we connect, we stay in geometry before, but we are going to use this new expression so that we can connect to the everyday life. So the first connection, of course, is going to be if this function, if you're driving on I-5 and we know your position function. Your position function would be against the time, okay, at what time or at a specific time, where are you? So this function would be the position function. X1 and X2 would be at the 2 different times that we're going to watch you. And if you find this average rate of change for the position function, you know that the top is going to be the kind of displacement, and the bottom one would be times, and the displacement over time, you know that it's going to be average velocity. So that would be the first interpretation for this expression for the average rate of change. It depends on the type of function that you're going to have. Okay, if your function is going to be the cost of producing X number of cars and 2 different level of productions, so that give you average cost. Okay, revenue, average revenue. So growth function, growth of the coronavirus at 2 different times. So that would be average growth. Okay, average growth, average decade. So it's very popular, and we can, we can extend it to be connected to everything in everyday life. Okay, so but we are going to be interested in particular on the physical one. So you have problems in your book. So in particular, if f of t is going to be the position function, is the position. Okay, it's going to be position of a moving object. Position of a moving object at the time t. Okay, it's going to be at time t. So we change the x into the t, then the average rate of change, then the average rate of, okay, the average rate of change of f of the function f from two different time, okay, from t equal to the t1 to t equal to the t2 is going to be given by the formula. Given by, our formula would be expressed in terms of the t. So it's going to be f of t2 minus f of t1 over the t2 minus t1. And in this case, it's going to be called average velocity. Okay, you must know it. And it's called, okay, it's called the average velocity. Average velocity. You use these expressions or this interpretation in calculus 3 as well, okay? It's going to be average velocity of the moving object. Of the moving object, okay, over the interval, the time interval, t1 and the t2. You have some problems in your book, and you have one your practice one. So we're going to question you this on this. Some people, they miss it on the test. It's a very easy term, but you have to know it, okay? So you have to know this expression that this is going to be called average velocity. Okay, so the average velocity and the average rate of change are going to be the same thing. Okay, we use the velocity definition because that would be easier, okay, easier to handle or easier to remember. Okay, any question? So far, this is mostly algebra. We haven't bring the calculus yet. It's just the extension of that, the notion of the slope that you did have. So we better give you an example. So similar examples are going to be in your book, your assignment, and we give one of them on the test. Just make sure don't miss it. Okay, and check your practice test number 1 that I posted for you. You see one, and you're going to see one in your extra point 1. That's going to be posted later. Okay, example. So don't be surprised. This is it. Suppose a position function would be given. Suppose f of t is simply given to you as t squared plus 8t minus 1. Is your position when deriving is the position okay, position, they give you the unit, in case it's going to be in miles of a moving object, moving car, for example, a moving, okay, moving object, let's say after t hours. Okay, so the t is going to be in hours, and the f of t, which is the distance, is going to be in miles. So what they want, they give an interval and ask for the average velocity. So would like you to find, okay, find the average velocity. Average velocity of the object over this interval, over the interval okay, over the interval written here. Interval is between 1 and 3. Between 1 hour, okay, and the 3 hours after you're just starting. Okay, so instead of average rate, they usually give you this one. Just want to make sure that you know the average velocity. Okay, are you ready? So the formula, remember, no derivative so far, nothing, just algebra. So the interval is 1 and 3, so it's going to be your T1 and it's going to be T2. And you know that the average is going to be f of T2 minus T1, f of 3 minus f of 1 divided by 3 minus 1. This is what you have to find for us, okay, to get the average velocity. Go to the function, substitute, find f of 3, f of 1. I just do it separately. Find f of 3, f of 1, come back, substitute, simplify, give us the result, of course, with the unit, because it's a velocity. Okay, so go and find f of 3. This is your function, substitute. So it's going to be f of 3. It's going to be 3 squared plus 8 times 3 minus 1. 3 squared would be 9, 24, and 1. Okay, so that gives you 8 plus 24, 32. So that's going to be f of 3. Then we find f of 1. F of 1. Substitute, so it's going to be 1 plus 8 minus 1. So we simplify that, give us 8. So I have the 32, I have the 8. So go back, substitute. So your average velocity is going to be equal to those quotients, f of 3, 32, minus f of 1, 8, divided by 3 minus 1. 3 minus 1. Okay, so the top would be 24, divided by 2, which is going to be 12. You have to give us the measurements. What's the unit for this one? Any suggestion? Unit for the velocity? You have
Miles per hour?
That's it, miles per hour. Yes, miles per hour later. Okay, you know, the top is going to be, the top is in miles, the bottom one is hours. So you have to say that miles per hour. Okay, you lose point if you don't give us the unit on the test, remember, because it's an application problem and you have to give us the, okay, the unit. So that would be the average velocity. Any question? So far it's all algebra. Okay, because for the average velocity, what you do is you have to wait, you check to see what's going to be the distance or what's going to be f of 1, f of 3. They are all precise numbers that we're going to do. So what we would like to do really is just a rate of change that we talk about it. You see, the rate of change, calculus is future, algebra is the past. So the rate of change means you are going to predict what would happen to your velocity, your rate of change for the next 6 months, for example. You invest money. You want to know what's going to be the rate of your interest, okay, your income for the next 6 months. So it's not going to be the average. It's going to be something that you have to define. So we have to answer a question because we don't have it. Okay, this is done. Algebra is done. So where is calculus? This is calculus. We are going to start with this question and we answer it. And this is very important interpretation of the derivative of the function. Would be so useful for you for future. Okay, so the question is this: what is? Okay, what is the rate of change? The rate of change. Okay, rate of change of the function. Of the given function f at x. You see as one. See, it's like the problem of a tangent line that we talk about the history. In the history of a tangent line, they didn't know how to define the tangent line to start with. And in this case, we have a similar problem. The problem is going to be how we're going to define the rate of change, okay? So what we do is this one. Again, calculus is the art of estimation, if you like, or prediction. You see what we did? We can do the average. In order to do so, the question is this one. See, this is X. Okay, this is X. So what you would like to do, you invest money. X is next 6 months. You want to know what's going to be the change in your income. So what we can do is we can change this problem into the problem of the average rate. In order to do the average rate, we need an interval, remember? So what we do, we estimate this one. This is the next 6 months. Okay, so make an interval for yourself. This is your target. You see your target is after 6 months. So to get my interval, you may go a little bit to the right, a little bit to the right, left. So I go a little bit to the right. Okay, so X is 6, I may pick 6.0102. So what I'm going to do, I'm going to call this one, okay, I call this X plus H. H is that estimate that I'm going to have. Okay, so H is very, very small. Okay, so this is going to be, this portion over here is going to be your H. Okay, so what I did, I just make an interval. I'm making an interval X and X plus H. You may say, what is H? H is any number you like. So H is a non-zero number. Okay, so I'm going to make a target for myself. Okay, I would like to estimate at X, but I go a little bit to the right, to the left. Okay, so as soon as I do this one, I have an interval. Since I have an interval, this is X1, this is X2. I can talk about the average rate. Okay, so this is the way we do it, and this is the way it's happened in everyday life. So we are going to assume, suppose, okay, suppose H is a non-zero number. Okay, an estimate, a non-zero number. And now consider what? Consider the average. Consider the average rate of change. Average rate of change. Okay, average rate of change of what? Of the function. Of the function f over this interval. Over the interval. You see, when we have the interval, we can do it. Interval. What is the interval? Interval is X, comma X plus H. Okay, so we make an interval. Remember, we want it at X. We don't want it at X and X plus H, but we're going to get it. Okay, I'm going to go to the next page, continue. So I want the target's going to be at X. So I move it a little bit to the right, to the left. So I have X plus H. So now I can find the average rate of change in this interval, then try to make it into the, okay, at X. So what is going to be that average rate of change? Okay, so this is it. So this is it, average. Okay, so that was the average. That's the average rate of change of F is equal to what? Remember the formula F of X2 minus F of X1. Now I'm going to have F of X plus H minus F of X divided by what? Divided by X plus H minus X. Now X and X would cancel out. Okay, would cancel out. I will get what? I'll get f of x plus h minus f of x divided by h. So that would be my average rate of change. Okay, so I know this is algebra for the time being. Remember, calculus is a dynamic part of your job. Algebra is a static. You don't move in algebra, but in calculus we moved. So I'm going to move. You see, we pick different h's, but close to the x. If x is 2, you may pick 2.02, 2.002, 2.0002. So you change the h as you move on. But anytime you change it, you find this quotient. You find this quotient, then when h is getting closer and closer to the 0, you see if h getting to the 0 is like the squeeze theorem that you're going to have. You see, when h goes to 0, this quotient over here is going to be what's going to be this quotient. If this is going to be the case, then this quotient f of x plus h minus f of x over h. You know that if h goes to 0, as we talk about it, or we just created, the top would be the rise, the bottom would be the line. So this is going to be the slope of a secant line. And each h goes to 0, this goes to the f prime of x. The slope of a tangent line that we created before. So what we have here, you see, therefore, the limit, or f prime of x would be what? Would be the limit of f of x plus h minus f of x over h goes to 0. Remember, you are interested in the rate of change of the function. So that was the average rate. But when h goes to 0, you see this is x plus h. When h goes to 0, x plus h goes to x. So that interval that we talk about it, that interval of x plus h and x plus h would be, there's not going to be no more interval, because the x and the x plus h becomes x, if you like. So instead of talking about the average rate of change of f on the interval of x and x plus h, you are going to see, note this one, see, look at this one, and note that if h goes to 0, then x plus h goes to x. Okay, and your average rate of change, you see the average rate of change of f over, you see, over of x and x plus h. You see that would becomes over what? You see, over x and x. That you can call it x if you like. So this will tell you that, so f prime of x can be considered, okay, can be considered as what? As the average, as the rate of change, no more average, because everything would becomes x here. So f prime of x can be considered as the rate of change, as the rate of change of f of the function f at x. You see, it's a very nice interpretation of that derivative as of the action that you're going to have. In fact, what I did is I usually call this one not rate of change. So again, I call it predicted rate of change. Therefore, f prime of x is the kind of the predicted. Okay, it's going to be the predicted rate of change. Rate of change of f of x. So means the derivative of the function is the future. You predict, you see whatever you did for the time x, okay, at the point x, if you want to continue, that will tell you what will happen to your investment, whatever you did. So f prime of x is a prediction. Calculus is a prediction. You see, when you generalize something in everyday life or the population, you predict. You predict that for the next 6 months, you see the rate of change of the rate of growth of your investment is that, or growth in investment of some bacteria like, like coronavirus, etc., is going to be the case that you're going to have. So this version of the formula that we have, okay, I repeat it again, f prime of x equal to the limit of f of x plus h minus f of x over h goes to 0. Again, this is going to be the derivative of the function. But in this form, you can use it as a rate of change, as a prediction for future to get this one involved. Any question? I'm going to do an example to make sure you understand this one. You see, so if in everyday life somebody asks you what is the derivative of the function, so it should be explained in this type of ideas, not the tangent line problem. It's the same thing, but this is going to be the interpretation that we're going to have. If you want to get a nice example, as I did, the way you are going to be given a ticket, you see, the ticket, the way they give you the ticket, exactly what I did over here. So you know that you are going to be ticketed if you drive on I-5 or I-15. You see, the first time, let's just explain it, the ticket. This is it. My neighbor is a policeman, and daughter usually asks the question calculus, and once he told me that, what's this calculus all about? I said, this is the way you are going to do it everyday life, and you give us a ticket, and this is how they do it. You see, this is X. You drive on I-5. This is the first time that the police camera will notice you. You see, the camera would notice you that at X. Then the camera is going to be watching you for the next few seconds, if you like. So you're just moving on. This is X. The camera sets something like 5 seconds, okay, 10 seconds. And the camera would watch you in this interval as you move on. As you move on in the camera, they are going to, you see, the camera, the digital camera that they have, they can quickly find your distance, if you like. The camera divide this one as you move on, getting closer and closer to the camera. And the computer inside it would evaluate this number. This number is going to be, yes, it's going to be your average velocity when you're moving towards the police car. You see, that's going to be the one. But as you're getting closer and closer to the meeting place, if you like, meeting the police car, this edge getting closer and closer to the 0. As edge getting closer and closer to the 0, the computer inside the camera would evaluate this number over and over and over. So the camera would register f prime of x as soon as you meet the policeman. So they register 95 miles, and as soon as you meet. So they show you at 95 miles and they give you the ticket. Why did they give you the ticket? Because it's a prevention. You see, when you have your velocity at the time, it's going to be 95 miles. That will tell us that from now on, at the time X, from now on, if we let you go, your velocity would be increased. Your velocity would be increased at the rate of 95 miles per hour. And probably you are going to have an accident. That's why that's a prevention, that the police car would give you the ticket. That's exactly calculus. Okay, that's exactly the because this is the rate of change that we're going to have from now on. So that's exactly calculus, that's exactly this definition that I gave you. And you can use it for any other things that you like to get, precise definition of the derivative of the function. Of course, if you are going to be a moving object, we call it rate of change, but in the case of the moving object, we are going to call this one, they call it instantaneous velocity, or the velocity of the moving object. Okay, any question? So I'm going to test you before, because you say we are going to have formulas, and our formula would be coming from here, and everybody nicely using the formula all the time, solve all the problems. But the important part is, did you understand it? What is going to be that f prime of x? What's the meaning? And how we're going to use it in everyday life? That's why we are going to question you like the following. Of course, you are going to find the details of this problem at the end of today, maybe tomorrow, but this is how we want to know what's going to be your interpretation of the derivative of the function before getting involved. Okay, so let's see this example. The example is going to be, you have some in your book. Suppose we don't have the tools to evaluate it, but we give you information. Suppose f of n, suppose f of n is cost function, is the total cost. Total cost in dollars. You will see the precise problem later on, but let's see what's your interpretation, understanding. Suppose f of n is the total cost in dollars of producing, producing n number of cars. N number of cars, okay? So we are going to ask a two question. The first one is, if f of n, I'm sorry, if f of 100 is, if f of 100 is going to be equal to the, let's say, $200,000. What does it mean, this expression? What does it mean? That's the first part. And then the second part, if we give you this one, if f prime of 100 is going to be $10,000, can you tell us what does it mean? What is the interpretation of these two numbers? And we create something on your quiz, your test, and you're going to find them, later on. Okay, so f of n is the total cost in dollars of producing n number of cars. So in the first part, we give you f of 100 equal to the $200,000. We want to know what's the meaning of this. In the second part, f prime of 100 is equal to 10,000. So what's going to be the meaning of the other one? For the first one, anyone want to try? In word form, what is the interpretation of number one? Let's start with number one.
It costs $200,000 to make 100 cars.
Excellent, that's it. It costs $200,000 to make 100 cars, or the cost of producing 100 cars is going to be $200. Very good. So that's the step one. So the first part, yes, the total cost, different version. I like this one. Your version would also was fine. The total cost of producing, okay, producing 100 cars is $200,000. That's it. You see, that's precise, and that's past, if you like. You produce it, and then you get these numbers. Very good. Any question? So in the actual case, the function would be given to you, then you substitute x equal to the 100, and that gives you f of 100. Okay, that's algebra. Second part. Any suggestion for the second part? Let's know f prime of 100 give you 10,000. Remember, f prime is the future, is a prediction. Any suggestion? Is a prediction, is a rate of change. Let's see, we have one here. Okay, and that's it. The hundredths car made will cost 10,000. Geneva, okay. Not bad, very good. Any other suggestion? You see, it's a rate of change. You just focus on the terms that we talk about it. It's a prediction. Remember, the f of n is cost of producing a number of cars. Okay, we have another answer. The rate at which 100 cars are produced, Ariane. So more precise numbers, what's that rate? Yes, it's a rate of change. Any other suggestion? You see, it's the rate of change of the production. The rate of change of the production for the future. So when we talk about the rate of change, there is going to be a level of production. It's like when you're driving. So when you're driving at a specific time, that give you the ticket, your velocity at a specific time, instantaneous. So when say f prime of 100 is as a level of production of 100 cars. So the best way, or the popular one to describe it, is this one. You have to focus on 100 cars. Remember, you're predicting something. So you're going to tell us after producing 100 cars, the cost of production, since it's a positive, the cost would increase. If it's going to be negative, the cost would be decreased. So we say after producing 100 cars, cost of production will be increased at the rate of $10,000 per unit, or $10,000 per car. You see, you make a prediction, then you think about it. Is it good for you? It's worth it for you, to continue the level of production after producing 100 cars, or going to stop? So this is the rate of change in your cost. Rate of change in your cost after production would be $10,000 per unit. Per unit, you have to focus on the level of production, because if you change different level of production, your cost may be, your cost may be different. So since they already given the 100, so this means, it's the next car. You see, this is, you already produce 100. If you want to produce the next one, it almost costs you $10,000. Okay, so this is going to be a different way to interpret it, is the estimate cost of producing the next car. What is the next car? The 101st car. Okay, so that give you stop here at 100. Then if you want to continue, this is going to be rate of change. It depends what type of function do you have. Since your function is a cost function, is going to be rate of change in your cost. If it's going to be revenue function, rate of change into revenue. If it's going to be growth, a growth function, growth of the bacteria, coronavirus, etc. So you just refer to that one. So the common expression that we use, okay, but you can change it, you know, a couple of you just answered it. That was also correct. But to be precise, you start with the level of production. That's it. After, this is the one I like, but I accept different version of this. Okay, after producing. After producing 100 cars, you have to give us the level of production. After producing 100 cars, the cost of production, the cost or the cost of production, since it's positive, will be increased. If it's going to be negative, will be decreased. Will be increased at the rate of $10,000 per unit. Per unit, in this case, going to be per car. That's the best way to explain it. You have to focus on the level of production. So the level of production is 100. So the cost of production would be increased at the rate of $10,000 per car. So just think about it. Do you want to continue or not? But equivalently, as a couple of you express it, and this means it's equivalent to tell us that, again, you can say that the total, the cost of producing the next car and additional car. Okay, cost of producing an additional car is approximately $10,000. Okay, and additional, okay, additional car. This is another way some people like to express it. Or even, you see, I like the first one. It's precise, nice, and you can use all the time. Or some other people that they said this is going to be this is going to be the approximate. This is going to be it is an estimate cost of producing the next car, producing the 101st. Okay, the 101st car. Some people like this one. The next car is going to be the 101st. Okay, so just get the meaning. Make sure you're happy about it, to be able to describe it. This is the way you are going to use it in your discipline. Okay, whatever you are going to be in science, okay, you're going to use the rate of change. So the rate of change is a kind of prediction. So whatever happened so far, and if you want to continue, you have to get this prediction for future. So the prediction is going to be f prime, but at different level would be different. Okay, f prime of 100. So it depends on the action of the function that you are going to explain it. So we give you one question on the coming test. Of course, you are going to find this yourself, and we do it when we get the shortcut. And then you find it and you explain it for us. Okay, explain it. The first part is algebra. See, that's the exact cost. When we say f of 100, it's going to be 200,000. This is the exact precise. But rate of change is an estimate. You estimate, you predict what would happen in future. Okay, that's going to be the prediction that we are going to do. And this is the way we operate in everyday life. Any question? So make sure you get a good feeling of this one. And you have kind of 3 problems in your practice test that I gave you. We go over it. And we also give you the solutions. But get it quickly to understand it before getting to the formulas involved. Okay, so just remind you that if you are going to be in physics, just give you a remark here for physics. I forgot to give you that. We are going to use this one. Remember, we talk about the moving objects. If it's going to be a moving object, so if f of t is the position, if you like, position of a moving object at the time t, then f prime of t is going to be just the velocity, or sometimes say instantaneous velocity. It's the same thing. It's going to be is going to be the rate of change, is the velocity. Okay, velocity of the object. Okay, at time t. We're going to have it, so we have the average velocity and the instantaneous velocity. I call it just velocity, but in your assignment, they call it instantaneous velocity. It's just you find the f prime and replace x and that to get that number. Okay, any question? So we are done with the definition. So what's going to be the machine? So the other okay, advantage of this new formula is when talk about f prime of x would be a function. So that gives you a machine. The one that I did for the strobe, we were able to find it as a specific number, f prime of 5, f prime of 2, f prime of 3. But this would help us to introduce a machine and to be able to bring the formulas. So let's just give you, we have a little bit of time. I give you this machine, then we bring the shortcut to do the job. Okay, so we get the interpretation. So what's going to be the formula? And this is it. We're just using this version and we introduce the machine for you. This machine is going to be called the derivative function. So we are going to introduce a function that will enable us to use formulas, shortcut, to find the derivative. Okay, so what's going to be the idea? The idea is what we did so far. You see, we got the x, remember? We drop it into the function machine. And that gives us what? F of x. That's what we did so far. So new machine, what's a new machine? New machine is going to be, we got the x, we drop it into the f prime machine now. F prime machine. So it's going to be f prime of x. F prime of x can be found by just using that rate of change formula. Is the limit of f of x plus h minus f of x divided by h. You see, this f prime is going to be called the derivative function. So there you are. If the function f is differentiable, okay, for all x, then we have the machine f prime. F prime is the derivative function. The derivative function. So we look at it as a machine, as a cashier. Okay, f prime is the derivative function that is defined by that's it, rate of change formula. F prime of x equal to the limit of, okay, rate of change, f of x plus h minus f of x, h, but h goes to 0. Okay, so if you want to prove something, we're just using this so-called rate of change formula. But if you want to find out a specific number, f prime of 2, f prime of 5, that tangent line problem would be more useful. Okay, so there's one example, and that would help us to bring the formulas, the shortcut. Okay, let's check one example, and the interpretation of that example will be the famous formula that we discuss it tomorrow. Easy case. Suppose f of x is x squared. We want to find f prime of x. You see, it's not f prime of 2, f prime of 5, f prime of x, f prime of 6 is f prime of x. So this means you are going to use it, okay, as a machine. So that's why you have to use this formula in order to get it. Okay, so let's find out a substitute to get this result. So the solution is going to be, don't worry, I just want to use this just to give you to prove the famous formula that we're going to use. And let's try this, which is easy to go. There you are, f prime of x, the formula is f prime of x equal to the limit of, I repeat the formula, f of x plus h minus f of x over h, substitute, is equal to the limit of h goes to 0, h, f of x plus h. You see, this is f of x, replace x by x plus h. So that gives x plus h all squared minus f of x, which is x squared. I just substitute x plus h squared. If you know a square of the binomial, otherwise x plus h times x plus h. So it's going to be equal to limit of h goes to 0. Now the top is square of the first one, x squared. Twice of the first times second, 2 times first times second, 2xh. Plus the square of a second one, which is h squared. If you don't know it, x plus h times x plus h. Boyle method, okay? A square of the first, x squared. You multiply these three numbers together. 2 times x times h, 2xh, minus x squared, divided by h, minus x squared. Now the x squared and x squared would cancel out. So what you have? So this would be the limit of h goes to 0. The top would be 2xh plus h squared over h. Factor out the h from the top. So that gives h times 2x plus h divided by h goes to 0. Now we cancel the h and h as a common factor. So that gives it the limit of 2x plus h goes to 0. Direct substitution. That's the h. So direct substitution gives you 2x plus 0, which is 2x. So there you are. F prime of x is equal to the 2x. Nice formula. Okay, so this simply means if the function is x squared, you bring the 2 down, 2x, that give you the derivative of the function. So the advantage is if you want to find the f prime of 2, it's going to be 2 times 2, 4. If you want to find the f prime of 5, 2 times 5, 10. F prime of -1, f of -2. So that's going to be the advantage of this formula. Okay, any question? Now we can repeat this one to get the famous formula that we have. Just give me the formula. So we are ready to practice it tomorrow. Okay, so this is what you did. So that's it. If f of x is equal to the x squared, then f prime of x would be 2x. So this is what we did. We bring the power down, 2. We reduce the power by 1 unit. So similarly, I'm not going to prove it, but similarly, if f of x is equal to the x cubed, then f prime of x would be, you bring the 3 down, 3x to the, we reduce the power by 1 unit. 3 minus 1 would be 2. See? Same thing. F of x equal to the x to the 4th. Then f prime of x would be, we bring the 4 down, x to the 1 down, 3. Okay, so in general, we make a formula. If f of x equal to the x to the n, then the derivative of the function, you bring the n down, x to the n minus 1. It's the one we call it action of differentiation. And you can use this one for the rest of the course. No formula needed, and use this shortcut for the rest of the course. And this is going to be called the power rule formula. The power rule. Okay, power rule of differentiation. Use it anytime you like, and we're going to use it, of course. This means derivative of x to the n, this is the way we write it down, prime, is equal to, bring the power down, n x to the 1 down. That's n, make it n minus 1. This is true for any number. Any number. No, we mean any number, we mean rational number only, of course. For any number, number n, for any rational number. Rational number n. And that's your key formula, okay, for the rest of the course. We call it power rule. We call it action of differentiation. Action of differentiation, you bring the power down, reduce the power by 1 unit. That will help us to be able to get through all the other problems that we're going to have. I'll talk about it tomorrow. So tomorrow I start with this one, and we move on with the formulas only. But for today, it's very important. You see, we spend a little bit of time on these type of ideas, because these are the ones that they are small points really, but very important one that we're going to use in future. Okay, so we start with this one tomorrow, and we give you all the formulas. By the end of tomorrow, you should be able almost to do most of the problems on that practice test that I posted for you. We go up to the section, end of the section 2.3 for the test. 2.4 is a chain rule. We don't talk about it, okay? So I think it's 2.1, 2, and 3. At this chapter, I should check it. I think it's the case, yes. We are done with the 2.1, 2.2, and 2.3. This is what we are going to do. So if you want to prepare yourself for the test, this is the way we are going to do it. But you'll be fine. Just wait for tomorrow and study these carefully to get the understanding of the concept. And then we're done. Okay, any question? So make sure that your quiz should be submitted for tonight and your first sets of assignments. Just finish that one on time, and then you'll be able to work on the test number 1. Okay, that's it. Let me know if you need anything, and see you tomorrow. Bye-bye.